this is kind of weird. So working with these square roots, all of this is kind of leading up to us being able to solve a quadratic equation that doesn't factor. Okay. So sometimes when you do that, you have to work with fractions. You have to be able to work with fractions and square roots. And sometimes you'll be working with a combination of those that doesn't quite work out nicely. Okay. So the goal today is for you to be able to rationalize the denominator of a fraction. Now, typically, when you do this, you're looking at a fraction with square roots that the denominator doesn't evenly divide into the numerator. So yesterday, we did some, say like 18 divided by root 3. And that's all well and good because you can divide 3 into 18. But these don't work. You can't divide 5 into 12. You can't divide 3 into 2. So there's this super easy process to simplify these or to kind of move forward with them. The only thing is it doesn't necessarily end in a nice answer. Okay, there's just a general rule in algebra that you cannot have a square root in a denominator of a fraction. Okay, I don't exactly know why. That's just not the standard. So we need to get that square root of 5 out of there. We need to get that square root of 3 out of there on these two examples specifically. But I can't just divide it out because that leaves me a fraction and the decimals and blah. So the trick is really easy. The trick is whatever the denominator is, whatever that square root is that I don't want in the denominator, I'm going to multiply the fraction top and bottom by that square root. Because the reason I can do this, this fraction that I just introduced into the problem has a value of 1. Square root of 5 divided by square root of 5 has a value of 1. So multiplying by 1, since you know from third grade, when you multiply by 1, you don't change the value. I'm just multiplying by a very specific value of 1. Okay, so when I multiply by root 5 and root 5, that creates a kind of a special case here. When I multiply the numerators here, I get square root of 60. And when I multiply my denominators here, I get a perfect square. 5 times 5 is 25. And then when I take the square root of that, it's just 5. Okay, so you're creating a special occurrence of the number 1 so you can get rid of the square root that's in the denominator. Now, back to the numerator, you'll still need to simplify that. So let's see, square root of 60, that's, I believe, 4 times 15. So that is going to be 2 square root 15 all over just a single 5 in the denominator. So by multiplying the top and bottom by that root 5, I created a more complex square root, which I could simplify there. Now, I kind of just jumped into this. If I had stopped and looked at it at the beginning, right, 2 root 15 over 5. Remember that, guys, 2 root 15 over 5. If I had stopped and looked back here, oh, this is 4 times 3, I could have simplified my square root from the beginning, right? And that would leave me 2 root 3 over root 5. And then I do this process of rationalizing where I multiply by root 5, and then I get my 2 root 15 over just 5. Oh, that's a janky looking 5 over just 5. So you could really do it either way. I would encourage you to wait until the end because it's entirely possible that I create another root that can simplify again. If you wait at the end, you only have to simplify once. So same trick here. I'm going to multiply by root 3 over root 3. So again, just 1. That's going to leave me root 6 over root 9, which we purposely created that perfect square. Okay, so root 6 over 3. These don't get any harder. The only thing is, like I said a couple of days ago when we first started messing with these, at the end of the day, when all this is done, your answer back here needs to be as simple as possible. So anything under a root, double check that and make sure it doesn't go down any further. Any coefficients or any numbers outside of the roots, make sure that those are as simple as possible too, as far as the fraction goes. What I mean by that is if I'd wound up having I'm going to make a number up here. If this has been 6 root 6 over 3, I could have worked with the 6 and the 3 outside the roots. Okay, couple more. All right, so I'm going to multiply top and bottom by root 7. So this is going to be root 28 over 7. And then 28 will simplify into 4 times 7. So that is 2 root 7 over 7. Now those 7s I can't do anything with because one's locked up under the root and one is free all by itself. So just kind of be aware of that. All right, top and bottom by root 8. So 5 root 8 over 8. And let's see, that is 4 times 2. So that is 5 times 2 root 2 is 10 root 2. Okay, and now I've got a 10 and an 8 that I can work with. So I'm going to divide both of those guys by 2. That is 5 root 2 over 4. Okay, I know I did that one really fast. Hopefully, you're all in class on Friday. Hopefully. So we can do a couple more examples like that. So root 12. So that is root 60 over 12. Let's see, 60 will go down into 4 times 15. So that is 2 root 15 over 12. 2 and 12, that is 1 root 15 over 6. If you want to put the 1 out front, you can. You don't have to. Now, this one, like all of these, if you notice before you start that your radical pieces have something in common, you can deal with that right away. So this goes back to Wednesday. I've got the square root of 8 divided by the square root of 2, so that is just a square root of 4. I can do that before. I don't have to rationalize this, but that is still getting that square root out of the denominator because I divided it into my numerator. So this is going to leave me with 2 root 4. Square root of 4 is 2, so 2 times 2 is 4. So that big nasty mess, 2 square root of 8 divided by 2 is just 4.